Hello you guys. So I've decided to go ahead and make a video for this week's lesson because we are going to go pretty quick. You are going to need to be independent and it just might be easier to communicate what I need you to do in addition to teaching it in class. So basically, what are we doing this week? You're going to explain how wind erosion affects the roundness and sorting of rocks. And we'll be learning about something called a Wentworth scale. Then the second part of this week's lesson is going to be how glaciers move and its effect shaping landscape. So let's just worry about the first part of the lab. So the Snoqualmie Valley has been developed by different types of weathering and erosion. So we're going to look specifically at abrasion. What is happening as these rocks are being broken down? So this slide talks about different types of abrasion. So the breaking down of the rocks due to the wind, and then the tumbling, the movement of the rocks. I will have you stop this video if you need to re-watch the sand analysis video. It's interesting to watch what he is seeing under the microscope. Unfortunately, not in the classroom. We can't do this ourselves. So watch that 4-minute video. Pause this, watch it, or you can just continue this because you've already watched it. All right, so next. This sand analysis, this is what you're going to be using for your lab data. All right, so you will be referring back to these charts. In your OneNote page, you have an example of clay, silt, very fine, all the way up to boulder. Open up your OneNote notebook and utilize that resource. It is in your OneNote notebook and it's called the Wentworth Scale Picture Resource. All right, and this is what that page looks like. You will be referring back to the roundness and the sorting. What I want to draw your attention to with the roundness is, see how angular these rocks are? And as you're moving through angular, sub-rounded, you're moving towards rounded. So there is a low sphericity or a high sphericity, meaning high circle, look how close to circles those are, or low sphericity, low circle, not really a circle, more like an oval, and then the angularity of it. So it could be very angular with a low sphere. Okay, now moving through. For the lab, you are going to open up your OneNote notebook and you are going to make sure you are on page 216. I have written down lots of the chunks for you. So the investigation question, how does the wind abrading time affect the roundness and the sorting of the source rocks? The source rocks are the 3 rocks that you put in your shaker. That's what those are. Now, in your OneNote notebook, I want you to write a hypothesis. The way you're going to form your hypotheses is fill in the blank. If the wind abrading time increases or decreases, pick one, fill in that blank. Then the mass and roundness will increase or decrease. You decide. So if I shake it more, then the roundness is going to increase, decrease. And then just some explanation as to why you're thinking that. What materials do you need to gather right now before you do the lab? Your 3 rocks, your homemade weathering jar, your analysis scale, which remember it's back up on slide 6, and a timer. What are you going to do? Well, you are going to put the source rocks in the weathering jar. But before you do that, use the roundness scale and record the average roundness and sorting for each of the source rocks. Initially, how does your rock look? And then you're going to record that under your initial. Take out a millimeter ruler and estimate, like you're kind of doing the best you can, kiddos, with the rock sizes. But what size are your rocks? Okay, and you can record those. And then what shape? Use that scale on slide 6. Use the sorting on slide 6. In fact, I apologize. The sorting. You can see how these are very angular and they're poorly sorted. They do not all fit nicely together. Look how these are like a puzzle. See how they're rounded, and then they are less organized than the well-sorted rocks. These kind of fit together, so kind of more like a puzzle, or are they overlapping is what you're looking at. Back to the procedure. So you are going to take your 3 rocks, put them in the shaker, start the timer, and shake them for that full amount of time. Remove them, compare them, and then record the changes that you've seen in your chart. Okay? And then you're going to do that up to 6 minutes. Fill in your last data for the 6 minutes. I included in here the graph. We'll go over it in class, but I did want you to see what we normally do with this lab in class is you are going to notice, so spoiler alert, as the abrasion time increases, so we've got 1 minute, 2 minutes, 3 minutes. As the abrasion time increases, you are noticing that the shape becomes more rounded. Okay. Your conclusive statements then are going to be something similar to that. All right. So how does wind abrading time affect the roundness and the sorting of the scale? The longer the abrasion time, the shorter the abrasion time, the rounder the shape becomes, or the more angular the shape becomes, and then what happens to the size? The larger the size, or the more organized the sorting, and you're just making a general statement like that from your results. So again, you take your OneNote page and you submit it to Schoology for your entire lab. So I am showing you what your OneNote page looks like. You will fill in the hypotheses because it's red. You will fill in the data table because it's red. You will make a conclusive statement, and then you will submit all of that by Control-P or the 3 little dots, print, and then you print to PDF. So again, what I've done is I've kind of tried to chunk this lesson for you. Watch that video up on the slides. I think it's like slide 3 or something. And then make sure you've got your shaker and your rocks. And then in OneNote, make your hypotheses and then conduct the lab. Use the scale on slide 6 to guide your analysis. After the lab, make your 3 conclusive statements and then submit the whole thing to Schoology. All right? Okay, I'll be around. Office hours, in class right now. Ask questions. Thanks, guys.